So here we go. Let's start on this webinar, Caring for Trees. And my idea for this was the horticulture of trees. And I thought I had a lot to say about it. And then when I put this together, it kind of distilled down to very few things. And so I have a tree here that on the title slide that's in the front yard of my Arizona place. It's a native sycamore. And it's probably grown there its whole life without anybody caring for it. And now I go out there and put the sprinklers on it because I want it to do well. And it's a riparian tree. It likes water, so I give it more water. But actually it got to be that huge tree without anybody caring for it. And I think that's a theme that runs through this whole webinar 4 in Caring for Trees, is that there's a whole lot of trees in the world that nobody cares for. Nobody has ever cared for them, and nobody is ever going to care for them. And yet they reach maturity. They're magnificent. They do everything a tree should do for us or for itself in its environment. And a lot of these trees are never even seen by anybody. They're just out there in forests or in their native habitat wherever they occur. And so what does it mean for us to care for trees? What is this really all about? I think I should probably call this webinar Having Your Way with Trees. Getting them to do what you want them to do, you evil, mad horticulturist, right? Because often what we're doing is we're cultivating something we have no business cultivating. We're growing some exotic in a place where it doesn't want to grow. And certainly some of my post-webinar questions have been about those things. People who are growing things that are marginal in their area and they're trying to get away with it. So this slide is not in the webinar, but I have a slide somewhere that shows the amount of time, money, and energy you put into caring for something based on its adaptability. And I don't want you to make the mistake that you've planted a native plant and you think that's the most adapted thing. Very often not. Native plants can be really fussy in the built environment, and they're not well adapted often to where we want to grow them. So just because something is quote unquote native to wherever you happen to be doesn't mean it's the easiest tree to grow or the best or the most adapted. So that has to be taken with a lot of research and thought. So in this webinar, we want to look at growth processes, and I've summarized these pretty much down to one slide, but I'll use a few more in support. Talk a little bit about roots and shoots. And I've come down to the 3 things that I think are pertinent to cultivating trees: irrigation, fertilization, and mulch. And we're going to eliminate fertilization in about one slide. So then it comes down to irrigation and mulch. And we can eliminate those pretty quickly too, but we'll spend more time on them. So those are the various areas. And this slide is here for just adornment. Is Quercus rugosa, is native here in the Chiricahua Mountains. It's also a native in Mexico. And it's one of the oaks that has pink new growth. Absolutely stunning. There are so many oaks with spectacular qualities. I would have you consider some of them. Well, get out your textbook. Here's plant physiology on one slide with no pictures, just to bore you all. But what are we really talking about? We're talking about taking light and carbon out of the air and making sugar. And the textbook equation is here in parentheses because that's not the equation that trees use. This is sort of a summary equation for all the reactions that happen that end up making glucose. But really what we make is this 3-carbon sugar in trees. And it's an intermediate on the way to becoming glucose, but that isn't what photosynthesis does. It makes this 3-carbon sugar. And so this is the actual photosynthesis reaction that most trees use. And the process of photosynthesis is the capture of light and turning it into sugar using water from the ground and carbon dioxide from the atmosphere. And then a tree can't live on just capturing energy alone. It has to utilize the energy. So once it's captured, it gets stored or used directly through this other reaction, which is sort of the opposite of photosynthesis. It's taking glucose and breaking it down back into carbon dioxide, water, and releasing chemical energy, and it's inefficient, so it also releases some heat. So this is the respiration, is taking that energy we've gotten and utilizing it in some cellular process. And it turns out there's a real hierarchy of cellular processes. And the highest demand or use of the first use a tree has is just to the respiration, that is the life of its own cells. So the background maintenance of all the cells in the tree that are alive has to occur through respiration. It's using some energy in the form of glucose to maintain its aliveness, if you will. And then come the uses of growth, use of energy for growth, the division of cells, making more cells by dividing them in half, and the production of fruit, the production of defensive compounds to attack pathogens. We'll talk about that next time. And so forth. So we have all these other processes, but the first responsibility of a tree is just to keep its cells alive. And so it takes a certain amount of background energy to do that. And trees store energy in order to always have some available so the cells can survive. Well, as part of this process to do photosynthesis, trees have to open the pores in their leaves, take in the carbon dioxide to make the sugar. When those pores open, and they have to have sunlight, so it's happening during the day, what's going to happen is that water vapor will leak out of the plant. And that process is called transpiration. So losing water out of the leaves is essential. It does a couple of things. It just opens the leaves so the carbon can diffuse in, but it also allows water vapor to go out, and the phase change of water takes with it a lot of energy. And so the buildup of heat, because photosynthesis isn't 100% efficient, it's only capturing a fraction of that energy. The radiant energy and other wavelengths hitting the leaf builds up as heat in the leaf. And the leaves have to deal with that. They have to get that heat out of there or they would soon cook. And so they do that by transpiration. So transpiration is the loss of water. And this is how all plants basically use water. They're running water through their leaves in order to get the carbon into the plant. And their efficiency in doing that is their a combination of how much water it takes to keep the stomates open to do photosynthesis and how much water that takes the plant. So about 90 to 95% of the water that goes out the leaf is not involved in the photosynthetic reaction. It's just used in transpiration to keep the leaf cool. Guttation is another process that happens in plants, mostly plants that aren't too tall, because it occurs when the stomates close at night. When the light turns off, the stomates close. Water can't go out through the leaves, then it goes out through other pores that don't regulate that way, called hydathodes. And so plants tend to come into a water balance at night where there's a small root pressure. So there's a little bit of a pressure on the foliage and the water oozes out. That's called guttation. And so we know that as the wet lawn syndrome. You go out in the morning, it didn't rain, but the lawn is wet. Yes, because all the stomates were closed and the leaves were gutating. And finally, the other big area of plant physiology or tree physiology is understanding hormonal regulation of plant growth. And it turns out there are a number of compounds that trees produce that have all kinds of effects on the tree and how it works. There's a hormone produced in the roots called abscisic acid, and it's a bad name because it doesn't cause the leaves to abscise, but it ABA regulates the opening and closing of stomates. And when there's not enough water, the roots will send that signal and they'll close the stomates even during the day to try to save water in the leaf. So there are many chemical practices that hormones regulate and is a big part of the physiology of the plant. So I'm trying to keep more words out of my talks so that it's more visual, and the pictures are really kind of talking points. And what we're talking about with physiology is capturing that sunlight energy in leaves, and then the leaves grab the photons and convert them into sugars that are moved into the vascular tissue. The sugars are sent to the sapwood and they're stored there as starch. And they utilize that starch in all their growth processes over their lifetimes. And that starch can even move within the wood, be depleted from the older sapwood and moved over to the younger sapwood. It turns out that the buds of plants are really important in their development. And we talked about this with pruning last time. If you missed last webinar, you might want to go have a look at that. The hormone auxin is produced in the expanding leaves and in the terminal bud. It flows down stems and it regulates or keeps other buds from growing. So when buds are intact and in place, lateral buds are less vigorous and they don't grow as frequently. And these processes regulated by auxin end up giving trees their shape. And so all trees have a predetermined, genetically determined shape that they will develop into if we don't mess around with them too much. And so we want to accept that and plant the tree shape that we want and then let the tree do that. And finally, because trees are good at capturing and storing energy, they provide food for other organisms such as this disease organism. And a lot of that food can be robbed from trees by fungi. And so they play a big role in how trees regulate their physiology. And in the final webinar, we'll talk more about that, how the role of pathogens in trees and what they mean for trees. So there are some simple truths about tree growth, which I think we lose sight of as gardeners and horticulturists and urban foresters and what have you. And that is that trees grow without people pretty darn good. So here is a picture of the town of Pripyat in Ukraine, a kilometer from the Chernobyl nuclear disaster, where the urban forest was abandoned for 30, well, almost 40 years now. It was in 1986. So quite a while ago. And the forest is thriving there. It's verdant. It's come in and taken over the city. In fact, it's taking down the city. It's taking over the buildings and collapsing them. And nobody's in there doing anything for that forest. It's growing on its own. And it's done amazing. And so there are remnants of the urban forest, and you can kind of see them here in the picture, trees that are planted along a street. And they're competing with the other kinds of trees that are coming in on their own. But trees require water, and they require the recycling of their organic material. And we have those two things here in Pripyat. There's enough rainfall every year to supply these trees, or snow in the winter. And nobody's picking up the mulch. In fact, mulch accumulates a little bit faster in places with a lot of radionuclides in the soil because it doesn't break down so quickly. But the mulch is there to recycle nutrients. And so these trees have everything they need. And if we think about horticulture, what horticulture is denying trees these basic needs, but still getting away with growing them. And that's where we need to think a lot. Where we choose to place trees, the amount of hardscape we surround them with, the things we do to soil in the urban environment. All of these things compromise a tree's ability to grow, and maybe to a point where it's not even sustainable. So in the sense of Pripyat and Ukraine and Chernobyl, litterfall, that is the stuff that falls from trees, is mulch. And it is essential actually to the survival of these trees. The nutrients that are contained in the leaves that fall and the branches and actually whole trees is recycled into the trees that are growing off of it. And so they get a little boost from a little extra, gamma radiation perhaps, but actually gamma radiation tends to slow down the growth of things a bit. And there certainly hasn't been enough radiation consistently over time there to stop the urban forest from reinvading a kilometer away from where the accident occurred. So the first thing we need to think about is the roots. We talked a little bit about roots in the other seminars, and we need to realize that roots explore the upper regions of soil. And that when we cultivate trees, we think about the tree part, the upper part, the shady part, the fruitful part, the part where the ecosystem services apparently occur to us, the part where animals visit, birds, etc. But we're also cultivating the root system. You can't forget that. You have to have a healthy root system to have a healthy shoot system. And roots require oxygen, moisture, and mineral nutrients, or at least the ability to exchange gases, because roots don't have leaves. They have to run on stored energy, the glucose that the leaves make, and they have to respire. So they have to exchange gases. They have to lose carbon dioxide. They have to gain oxygen. And they can't do that in bad soil conditions. So roots also grow where microbes grow. And roots are largely reliant on microbial processes in soil for their own health. And we'll talk more about that in the last webinar, not so much in this one, but the favorable conditions for root growth are very often the favorable root conditions for microbial growth. So I really like this picture from a soils point of view. It shows a lot, and we could talk about it on the soils basis, but I'm not going to. This is a forest, an oak woodland in Sierra Vista, Arizona, and it shows you pretty darn clearly where the roots are. They're all up here in the top 2 feet. And there's not so many down here, some maybe, but not so many. And the soil up here is a little bit different color. It's darker, it's dark brown. And that's because it's been modified by the organic matter accumulation, the litterfall or the mulch. And the color has changed a little bit because of the organic acids in the organic matter. But this is where the roots want to be. And this is not because the soil is poor down below or compacted or anything like that. It's because that's where the roots want to be. And we have to realize that with trees. Trees are shallow rooted creatures. And there's some silly notions in horticulture that if we irrigate deeply, the roots will go deep. Well, no, they don't. They don't follow the water per se. They will grow where water is, but they will also grow where oxygen is. And we have to remember that roots want oxygen and moisture. And they certainly don't want conditions like this, conditions that are so compacted. And you see the tire track that went right over this area. So you have compaction and water that won't infiltrate and it won't drain very well. So we don't want the low oxygen environment. We don't want flooding. We don't want small soil volumes for trees. This is why trees don't grow for very long or live for very long in really urban settings like here in Kiev. What about fertilizing landscape trees? I have one word for you: no. Most of the time, no. Not without a reason, not without some soil chemistry lab work that tells us what it is we need and why we're fertilizing. And if you're using fertilizer materials to achieve changes in pH, for instance, that's legitimate if that's what you think you need to be doing. But you need to have a plan. You can't just go buy a bag of fertilizer and throw it down on your tree and call that responsible horticulture, because you might be polluting waterways doing that, adding to the nitrogen burden of the runoff water in the creeks. And this is something we've got to stop doing. We can't just keep fertilizing everything sort of willy-nilly without thought and without care for what we're doing. Nobody fertilized trees 200 years ago in any real systemic way. What about 200,000 years ago? There was trees. Did anybody fertilize them? No. We don't need to fertilize trees. sometimes if we're growing a tree that's not adapted to the area we're growing it in, or we have a soil that is fill soil, or it's been changed, or it's somehow lacking a certain mineral nutrient, fertilization comes into play, but it has to be done from an informed perspective. And so I would say when you're fertilizing things, you have to have some knowledge behind that, not just get out a bag of all purpose and throw it down. And irrigation is the same way. And we'll talk about the regionality of irrigation here in a second, but I just love this image of a soaker hose bundled around a tree trunk with no thought. You know, that's not going to do anything. And it's sort of a joke picture, really. But irrigation is actually very, very complicated if it's something that you're providing for the tree. And I'm not talking about supplying, you know, nature's supply of water to trees in native environments. That's a completely different discussion. I view irrigation as much like fertilization. Basically, no, you don't need to do it until you do need to do it. And then it's an informed decision. In much of the Western United States, we're in a pretty bad drought. We're not getting the amount of rainfall that we think historically we should be getting. And we're also in increasing heat waves, so increasing amounts of stress. And as you'll see in a minute, I'm going to suggest to you that irrigation should be used to reduce stress. So irrigation, calculating the amount of irrigation a tree needs is really very complicated. Ideally, we would sum up the amount of water lost from every leaf and calculate the amount of water we need to replace that loss through transpiration every day. And this is sort of done in models that use ET, or evapotranspiration, which is the combination of evaporation from soil surface and transpiration from plant surface. And we can model, if you will, what the reference demand for that is and match it with irrigation. So we can add up basically the ET for every day, say a quarter of an inch of ET today and an eighth of an inch of ET tomorrow. And this is based historically off the amount of water that evaporates from a standard weather pan. So it's basically just a pan of water, and you measure how much it goes down every day. And you go, well, looks like we evaporated from that pan this much water. We multiply that by a crop coefficient because every plant has a little bit different water use. And then we come out with an amount of water we suggest we should put back in the soil. And so these models have been developed in agriculture, and they work very good in agriculture because in agriculture, we have a big block of the same kind of plant evaporating the same amount of water, and we can then estimate how much we need to put back. Does that work in landscapes? Well, to use a word, no, it doesn't, because landscapes are not a big block of the same kind of plant material. And so the water use of all the different components is different. And it's hard to use ET-based scheduling on landscapes or individual trees. So I don't advocate ET-based scheduling or ET-based controllers for tree growing trees. I think it's silly. But what I do advocate is understanding the model, the concept that the climate demands a certain amount of water because of vapor pressure deficit, which is relative humidity, basically. And understanding that when relative humidity is low, plant water use goes up. When there's more wind, plant water use goes up. When the days are longest, plant water use goes up. And so there are various things that drive these models that we do need to understand. And in a general way, we then come to an understanding of when we need to irrigate to reduce stress of trees. So certainly rainfall is a part of the equation. When we have rainfall, we can subtract it from the amount of water we need to supply. And certain parts of the country can rely on rainfall and other parts not so much. complicating this is the fact that different soils hold different amounts of water for different amounts of time. So understanding the soil moisture capacity and the amount of rooting and to what depth those roots go also tells us something. It tells us how deeply we have to irrigate to supply those roots. And relatively, it tells us how much water the soil will hold. And that tells us then how long we can run the sprinklers or the emitters to fill that soil up with water to supply irrigation for a certain period. So when we are applying water for trees, we can have salinity issues because the applied water may or may not have salts in it, unlike rainwater. It's nice where it rains because you're getting these leaching fractions all the time, and salt is not an issue. And in fact, just the opposite may be the case. Your soils may be leaching because of high rainfall. And then we come back to fertilizing because we may need to replace some of the elements that were lost due to excessive leaching. So another thing that's confusing and difficult is tree size versus water needs. A lot of times irrigation systems are set up when landscapes are installed and they apply a certain amount of water for a young tree, but the tree grows and needs more water. Contrary to what a lot of people seem to think, the older the tree gets, the more water it needs, not the less. And I think this is doubly confusing because people see established trees, large trees, older trees as being able to deal with drought, and they're established so they don't need to be watered as often, right? That doesn't mean they need less water. They need more water. It's just maybe their root systems are more capable as they're established to get that water they need without help from us. So the placement of water changes over time as the tree grows. Its roots explore larger and larger volumes of soil that need to have water in it if they're going to be able to grow. So we're having drought in the Western United States and in many areas. Oh, Tracy, you have a question.
I would like you to address the failure of Betula, pendula, and similar in the areas that we're experiencing now. You have a question about that, and it's appropriate for this area of your
Well,
talk.
there's Betula pendula on the slide. What was the other plant again?
I was just saying, you know, birch type trees in general, alders
Oh,
and similar.
okay, I get it. So here we see a couple of things in this slide. We see trees that have died, basically failed. The Betula here in the picture with the truck, and trees which are avoiding drought, liquid ambar in this slide, they have not died, but they have not, they don't have leaves on because they're avoiding drought. And so there are a couple of consequences. And the irony here is that in this picture, here's a liquid ambar that's bright green, that's doing great, and it hasn't died, while these birch have died. So clearly drought can bring all the species in this picture to their knees and even to death. And it has to do with adaptations. In Southern California and in hot inland valleys, particularly Ojai, where this picture was taken, birch are rather short-lived, and they're not going to be well adapted to our water regime, our high temperatures, and competition with other plants. They just need a whole lot more water than most people are willing to provide. Other species like liquid amber, they die for various reasons, or in this case, they defoliate because there's been no water on this landscape. And this is actually in a higher ET area. This is in Ventura, not very many miles from the coast. And so you would think they would hold on better here. And this one's in Ojai, where there's a lot higher ET. So there are a lot of moving factors, and understanding tree response to irrigation, to drought, and to climate change, which I would suggest to you is what the thermometer is showing us. This is over 120 degrees in Ojai, California, and it's not supposed to be ever 120 degrees in Ojai. This is unusual. And yet we've had this occur now 3 times that I know of. And so this is our warming climate. All of these things impose stress, and knowledgeable irrigation can relieve stress. I don't know if I answered your question, Tracy. One of the
I think you did.
Okay.
The salinity and the lack of appropriate environmental conditions for birches mainly, but
Mainly,
for
yes.
the liquid ambar, it is situational. Is that what I'm understanding you to have said?
Correct. And also, we'll see in the next webinar, it's also maybe pathology involved.
Awesome.
So again, this is something we suffer in the West. This is Henderson, Nevada, showing you salt crusting on the surface of an unprotected soil. And when I say unprotected, I mean uncovered, i.e. no mulch. And so where we have evaporation way exceeding any amount of precipitation, we tend to build up salts. And those salts can accumulate in the upper layers of soil where trees also want to have roots. And that can be harmful, at least in terms of the success of some sensitive species of trees. Mulches can help with this. And we're going to talk a lot more about mulch, but I wanted you to see the image of salt building up on the soil surface. So irrigation placement is another issue, and this is bad placement of water when it hits a tree trunk like that with an emitter that is made to irrigate turf grass. And again, this is an incompatible association of turf grass with trees. We don't irrigate turf the way we irrigate trees and vice versa. And so there's not a good compatibility here. With irrigation, we have to consider the rate of how much water we put out at a time, because a soil can only take in so much water at a time. So matching the infiltration rate of the soil with the precipitation rate of the emitter, it's a complicated thing. And I would say most landscapes don't get that very good or do it correctly. And we have to place that water where it needs to go to irrigate the tree. And we have to do it frequently enough to benefit the tree. And some people would think, well, shoot, I never water my trees at all. Yeah, that's because you're somewhere where you get summer rain. And that's not what we get in California, at least the part we live in. We get no rain from March until maybe the next March. Some years, it seems, we get zero rain. But literally, we get no rain for 6 to 9 months of the year. And all of our rain comes in the winter. And so when you live in a place like that, a so-called Mediterranean climate, you may be using irrigation to stave off stress. And so even in such a dry environment as what Tracy and I are dealing with, it doesn't mean that we irrigate every week necessarily. Much to the contrary, we may be irrigating some trees 3 times a year, depending on the tree, the landscape, and the soil it's growing in. Well, certainly a tree growing in a sandy soil is going to need much more frequent irrigation than a tree growing in a clay loam. So the edaphic factors, the soil factors, have a lot to do with how frequently water is depleted from a soil. And gravity will deplete water from a sand soil, let alone without plants in it. But a loam or a clay soil or something with organic matter in it is going to hold water longer. And so we will have to irrigate less frequently. And finally, incompatible landscape features create incompatible emitters, that is trees and turf grass. These are not good compatibilities. So the Israelis were the champions of drip irrigation. A lot of people say they invented drip irrigation, and we started using their ideas in our climate. And we refer to this as Netafim, but it isn't always Netafim. There's a lot of this that's not. Netafim is a brand, and basically it's half-inch drip hose that has emitters at some sort of spacing, usually 1 foot apart, and usually 1 gallon per hour emission rate. And so you can calculate the number of feet of this around a tree and add up the number of emitters in that tube times the number of gallons per hour and figure out how much water is going to go down in that area. So this has been adopted in a lot of places that have high evaporation rates. A lot of California uses this kind of drip emitter. And I would just say that it's effective if used intelligently for some of a tree's lifetime. And then at some point, it's not so effective. And it's not effective then because it needs maintenance. These things can plug up. I know here in Arizona, we have this in the apple orchard that I have. And when I went and reviewed the efficiency of this system, about half of the emitters in the net-FM tubing were clogged. And so one of the beauties of this product, though, is you can go out there with an ice pick and basically jam it in the emission hole, and it will start to re-emit with about the same 1 gallon per hour rate. The net-FM is tough, and you can just basically physically push the salts aside and make it work again. But the fact is, you have to go do that. You can't just install it and say, okay, I'm good for the tree's lifetime. That doesn't work that way.
Can I interject one point?
Sure thing.
Additionally, many people are burying the net-FM, which makes it completely inaccessible, and you absolutely cannot then manage that clogged orifice unless you have an inline injection system for acidification, which is not yet manufactured for the homeowner level products.
Sure. And so, you know, irrigation systems, I think most people would say are best not seen. Just maybe you like to hear them running and spraying the water, but people don't want to see it. And so they bury it, they cover it in mulch, they do all these things. But then how do you know if it's working? You very often you don't know if it's working until you see something wrong, or you see something flooded where it broke. And so the big problem with any irrigation system is the maintenance. It all needs maintenance, and it needs checking on all the time. And so how much do I irrigate? Well, somewhere between Kiev and the Namib Desert is just about right. I don't know what that is for you. It has so many moving pieces. The age of the tree, the size of the tree, the soil type, the climate, whether or not you're in a drought, how hot it is, how much wind just blew, whether your relative humidity is high or low on any given month. And so all these things change the schedule. And even if you have so-called smart controllers that think about all this for you, they're not going to get all that right. They have no idea how old your tree is, for instance. A smart controller is just something that is programmed to do things, and maybe it has input from some sensors. Maybe it has weather data input. It has no idea how old your tree is or whether or not your tree is dead, like the one here in the Namib Desert. Nothing is going to bring that back to life. So irrigation also depends on climate. And so I made this up tongue in cheek, but there's actually a lot of truth in it, is you need to irrigate in the West and you don't need to irrigate so much in the East. And sure, there's obviously exceptions. There can be a drought going in Virginia, okay, although I've never heard of it. There's always a drought going in Arizona. I can just guarantee you that, and in California. And there are some awfully wet places in the Pacific Northwest, like the Hoh River Valley in Washington, and the national park there. And so those are very, very wet places. It rains more there than probably anywhere else on the continental United States. So sure, you don't need to irrigate probably there, but I've been to the Hoh River Valley when it was dry too. And so even in a wet place like that, drought can occur. But in general, the climate is what's determining whether you need to irrigate. And, Texas is an interesting place. half of the state is very dry and half of it is very wet. And when you go to Texas, you think, oh, Texas is dust and cows, right? Well, no, it isn't. It's forest in the east and it's scrubby desert in the west. And so it's very different, and it falls right down this dividing line here. And places in these Midwestern states can be very droughty. Read Dust Bowl. And some of this is tied to the amount of organic matter in the soil. So the wet places, and there's probably a lot of coal in the soil here, but the wet places have huge amounts of organic matter. And we see up here along the Pacific Northwest where it's very dark. And the dry places have less organic matter. It's not as much vegetative growth, and so we don't have as much deposition. But forests are still messy, organic-y places. And this is again in my backyard, full of fallen debris, leaves, branches, litter, dead animals, mulches. This is what a forest looks like when nobody's picking anything up. And this is organic matter deposition in Arizona. This is occurring here because this is an area that gets more rainfall than most of Arizona. And it's also in a riparian corridor. So there's just naturally more moisture in this little spot. But that litterfall space allows for nutrient cycling. So nobody's fertilizing those trees, but the litter that's falling on the ground. And it's breaking down and fungi are growing in it. And so in this environment, we don't need as much fertilization. The minerals are tied up in the organic phase of the tree's recycling process. And in landscapes, this basically equates to mulch, and it gives us somewhere to put our green waste, actually. I kind of envy the, I don't know, idyllic notion that we could keep our system self-contained, that we don't need to dispose of green waste, we reutilize it. We put it back in the landscape. Tree trimmings don't leave the property, they become part of the property. They get chipped and put back into the landscape. And this is what we need to do. We need to conserve our organic matter, keep it going in the landscape as a part of the landscape. This creates a more sustainable landscape, but it's also one wherein we have to look at mulch. And I have to relate a funny story. I was consulting at a millionaire's residence, and it's a place of 10 acres on the coast of California near Montecito, California. Very, very wealthy person. And they had recreated a jungle there. And it was so ironic because the owner did not want to look at mulch. He was having them rake everything up under this very highly cultivated jungly landscape and did not want to have any organic matter on the ground because they didn't want to look at it. But that's exactly what that kind of plant environment wants. And it creates for itself. Forests create mulch and they fall on the ground. We call it litterfall, and it's essential for their growth. So what do we create in urban plantings? We create settings like this. This is the Auto Club parking lot in Ventura, California. That's not a tree-friendly place, but this evergreen pear is tolerating it. And it's also tolerating being run into by cars and backed into. It's just such a tough tree. But is this ideal for tree growth? No. Restricted root volume, little or no irrigation, no organic matter inputs. It's terrible for trees. So trees also support microorganisms, and most people probably don't think about the impact mulches have on microorganisms, but it's huge. So the bare soil, this was taken from one of my classes in plant pathology, where we had an exercise of plating out our soil. And the soil mulched with wood chips for 10 years is on the left. And the soil from the horse pen, where nothing had grown for 25 or 30 years, basically bare soil for that whole time is on the right. And so you can see that soil can be basically killed by depriving it of oxygen, because the horse pen is compacted, highly compacted soil, and no organic matter input except piss and horse manure, which is removed as best we could do. And so it's a huge impact. Organic material increases the number of fungi in soil, and that is because fungi need carbon to grow. Without carbon, they can't grow. They're mostly saprophytes. But they have other roles, and we'll talk a little bit more about this next time. But here we see two fungi on the right and left, the same fungus, Chaetomium, inhibiting this pathogenic fungus called Phytophthora. And so you can see the Phytophthora is not growing, and the Chaetomium is exerting some red substance into the agar medium, which is an antibiotic. So fungi have this role. They can inhibit the growth of opportunists or pathogens by producing antibiotics, and we call that antibiosis. So these organisms play a crucial role in soil in protecting roots of trees by producing these antibiotics. And that one, there we go. That didn't want to display right at first. So another thing that happens in soil is called lysis. Lysis is where cells are broken open, and some fungi create enzymes that destroy the cell walls of other organisms like Phytophthora. And this was what I largely worked on for my PhD, and showing that organic matter in soils has a big role in stimulating the production of these enzymes that destroy the pathogenic things that want to hurt our trees. And finally, organic matter has a role in providing the food for fungi that want to eat pathogens. So here you see one fungus coiling seemingly around another, but the one that it's coiling around is a Phytophthora, which is not a fungus, but an oomycete. And this coiling fungus is a fusarium, and it's trying to penetrate and attack that plant pathogen. So there's a role for fungal hyperparasites that get in there and they try to attack fungi that are harmful to trees. So this mulching thing, here we are at Cal Poly in Pomona, and there's a tree and turf, and it's not the best place for a deodar cedar to be in a lawn, but here it is. And they have put a mulch ring around it. How much of a mulch doily is going to be effective? That's an interesting question. And Richard Harris at UC Davis 45 or 50 years ago found out that a 3-foot ring could make a big difference for a young tree. Just having 3 feet of no turf and mulch, as opposed to 3 feet of bare soil or any other condition, is going to be helpful to a young tree. So this tree has a bigger ring, and it's basically equivalent to the drip line. And if we could maintain that mulched area as the drip line grows, so that the entire drip line of the tree was mulched, that would be beautiful for a tree, because that's more or less what happens in nature. The tree can drop its leaflets and needles or leaves or fruit on the ground underneath it, and its root systems would be benefited. So mulching is fairly a new practice in Southern California, I think. We do mulching a little bit, but we don't do mulching as much as in some other parts of the country or even the state of California. And we should be mulching much more frequently for trees. But it's been a design problem because most people don't want to look at mulch. After years and years of doing research and talks about mulch, I look upon mulch as beautiful. To me, it looks great. You know, I just think that that's wonderful. The other thing is that we can use mulched areas as a place to put our green waste. And green waste is recycled in most cities of California. It's required by law to be recycled. And now almost no mulch is allowed, or green waste rather, is allowed in dumps. It has to go back out somewhere in the environment. And for years, That somewhere ended up being along freeways and big piles or just off somewhere to get rid of it because people didn't see the value of it. But it is valuable to trees and we need to be using it more often. So the urban environment for trees is challenging. And, this is again, from Europe, from Kiev in Ukraine. And we see weeds growing. We see the tire print, which means the soil is being compacted. We see this token mulch, which somebody thought, oh, trees need mulch, so they put some down. Well, I guess some is better than none, but that's not an effective amount of mulch to support a tree. It needs to be much more than that. And then gets to be the question of what kind of mulch. And this is something that maybe goes against some people's thinking, but compost is not the best mulch. We want to be using fresh wood chips, and we don't want to be using composted materials. And I'll explain why. So compost is already decomposed. Its energy has been consumed by the microbiology in the compost pile. It has nutrients available because the carbon has been boiled off through respiration. And so there's nutrients. It acts as a fertilizer, and that's okay. And that's why compost sometimes stimulate things to grow. But the microbes in compost are either dead or in stasis. The texture is usually too fine if it's been screened. And salt levels may be toxic depending on what the feedstocks of that compost were. For instance, manures. You may be applying something to trees that is simply too hot. Fresh tree chips, however, what just came out of the chipper, have not decomposed at all. They contain a ton of energy, and by energy I mean raw, unchanged carbon or carbohydrate or cellulose in the product. And so that is energy for microbial work. The nutrients are pretty much fixed. They aren't available to plants right away. But that doesn't mean that they won't become available years down the line. They do. The microbes are just beginning to multiply. The texture is coarse, and salts are not yet a problem. So when we put this on the surface of the soil, it has a completely different effect. It doesn't supply nutrients right away, but it does supply carbon. And that is supplying the energy for growth of microbes in the soil. So in essence, you're putting down food for soil microbiology by putting down fresh tree chips. And when you put down compost, you're applying something that by definition of a good compost is already dead. That is, it's not active. It doesn't reheat when you repile it. It's stable, it's mature. Those are all terms used for compost. And in essence, you're basically saying it's a fertilizer at this point. And if you recall the earlier slide, do we fertilize trees? The answer was no. We encourage them to grow by providing a soil environment they want to grow roots in. And that isn't necessarily a compost applied soil. So what we're really trying to do is stimulate this, the trophic network or the soil food web, going everywhere from bacteria to cow and person, all a part of the soil food web, and certainly the tree. Now, the tree is also a part of the soil food web or network. And in this case, since this slide was made by a nematologist, you see a lot of nematodes. So there are many, many different kinds of free-living nematodes at all the various feeding levels in the soil food web that indicate its complexity and its resilience. So it turns out, just speaking food web speak for a second by Dr. Howard Ferris at UC Davis, the more complicated a food web, the more resilient, the more structured the food web, that is, the more reliance each trophic level has on itself, the more compatible for plants to grow in, and the less compatible for opportunists to grow in. And what is an opportunist? An opportunist is a pathogen of a plant. It's looking for an opportunity where the plant is disadvantaged. And Dr. Ferris's work would suggest that um, when the various guilds of nematodes become compromised and you start taking apart the connections in a food web, then it becomes less resilient and opportunists have more of an ability to cause disease or to interact with plants. They get out of balance. And so that's the story very shortly that would really take a couple of webinars to go on about. So there's another effect of mulches that I've seen through my research over the years, and this is the effect on rooting. And this was the first mulch study I ever did growing sycamores, and we measured rooting. And here's pine bark mulch, biosolids, which is a compost, eucalyptus that was composted, fresh eucalyptus of the same species of different sized chips. And so the fresh eucalyptus large chips ended up producing significantly more roots than some of these other treatments, but all the mulch treatments encouraged rooting. And that's the thing you should realize, that mulches encourage rooting. You put down mulches, you're going to encourage woody plants to grow more roots near the soil surface. That's a good thing and also a difficult thing, because it means you have to manage those roots and the moisture that they require that are now near the surface. So in some sense, you have to irrigate more frequently to deal with that. But in another sense, you're empowering that woody plant, whatever it might be, to grow more because it has more roots. And so this is really a mulch thing. Mulching makes roots. And I said, when you put down mulch, you're not putting down so much nutrients right away. But in time, as those mulches break down and you keep adding more, they do lead to more nutrition, mineral nutrition under the soil. And this was from a study we did in citrus, where we followed the deposition of nutrients 6 inches down under the mulch based on the thickness of mulch above. And so the blue bar is no mulch, 1 inch of mulch, 3 inches of mulch, or 6 inches of mulch. And you see this very linear effect on N, P, and K. So basically, the more mulch you put down, the more mineral nutrients accumulated in that soil over time. And this was a loam, clay loam soil with yard waste mulches applied over the top in a citrus orchard. And so these were all applied fresh. There was no compost involved here. And so many of you may have the idea that, oh, mulches are going to tie up your nitrogen. Well, mulches do not draft nitrogen. They do not suck nitrogen out of soil. And in fact, just the opposite is true. They end up adding nitrogen to soil. And so there is no published evidence of surface applied mulches sucking nitrogen out of soil, despite what you might have read in gardening magazines or other popular sources. And so there are a variety of, I see a hand up, but we'll take questions at the end. There are a variety of other analyses that we can look at, and this is indicating whether the mulch was significant or not. And so in this study, these trees have been mulched for 3 years by eucalyptus, and again, fresh eucalyptus, not anything composted. We saw the moisture content go up a little bit in the soil under the mulch, so the saturation percentage. The salinity stayed the same, no difference. We saw nitrogen go up significantly, phosphorus go up significantly, and potassium go up significantly. We saw sodium go down significantly, which is something we don't want in soil. And we also saw, of course, very significant increase in the total amount of carbon in the soil, and the pH stayed the same. It was around neutral, and mulches tend to bring the soil back to neutral, whether it's an acid soil or an alkaline soil. So this was sort of an expected result. So this is the thing. The more mulch you put down, generally the more plant beneficial nutrients will accumulate. And so this should be leading you to a question of, can I over mulch? Well, probably yes. There is been documented cases where people had been trying to get rid of mulch because mulch was considered trash. And so we had an issue in Ventura County where LA County was trucking semi-loads of fresh green waste to orchards in Ventura County. And some of those orchards were along the Santa Clara River, and they were mulching to depths of 3 feet deep. And that is going to, in time, put a nutrient pulse on a sandy soil near a waterway that's going to impact the waterway. So yes, you can overdo it, and you shouldn't overdo it. But I want to reiterate the point that freshly applied wood products on soil surfaces do not immobilize nitrogen. And this is a picture from my orchard in Portal, Arizona, where I've used sawdust from a cabinet shop. The cabinet maker brings me his sawdust, which he saves, and I apply it in my orchard. Now, I've been putting fresh wood product on the ground for 2 years now, and I don't fertilize these trees with nitrogen. They get 0 applied nitrogen. All they get is sawdust. And their nitrogen content is great. It's sufficient. There's never been any deficiency here. So when you apply mulches, you can apply very fresh wood products, and you're going to get beneficial soil results, and you're not going to immobilize nitrogen. I see lots of hands going up now, but again, we'll hold questions. The only hand I recognize is Tracy's. So Tracy, go ahead.
My hand is up. So speak a little bit to the particle size of the sawdust and irrigation issues that might arise from using that material.
Yeah, I haven't had any, but I'm doing a couple of things. I'm irrigating with Netafim, which is drip, which is under the sawdust, and I occasionally pull it out and check it. And then I'm irrigating also with sprinkler emitters that I run off the end of a hose when I want to really soak an area. And I have no interface issues, and the particle size is what a table saw makes. So it really is sawdust. And it's been fine. I haven't had any immobilization issues. I haven't had any infiltration issues. It's only been good. Now, it's not the best looking thing, in my opinion. I wouldn't do this in my landscape. It doesn't look particularly nice. But this is an orchard, and the biggest problem I have here are chickens. The chickens like to dig in the mulch, and so yeah, that's kind of a problem. So I want to talk about the canopy for a bit, and this is just one slide on the canopy, but you know, decreasing the canopy of trees is not good for trees. Trees don't want to be pruned. They don't want to be shaded. They don't want to be diseased. Conserving the canopy conserves the tree. And I think we're coming to this place in our industry. We're beginning to understand this. But to many people, the image on the right looks like a good thinning job. You know, it's like, oh yeah, they trimmed that thing really nice. Well, no, it's actually quite destructive to the tree. So keeping a full canopy and a dense crown should be the objective in cultivating trees. Also want to talk about landscape retrofits. This is a very 60s landscape on the left from my town in Ojai, in fact, on my street in Ojai. And it's showing you a lawn with a big cankered willow tree, big canker, but it's a weeping willow and a nice tall fescue lawn. And here's an alder tree. In this area, they renovated. And in fact, the entire yard was renovated, and they went to this DG landscape with a rock and the DG. Well, that tree lasted about 1 year in the DG landscape. Why? It's a riparian tree, and you DG'd it. Well, you're going to kill things that way. It's inappropriate landscaping. It's a riparian plant in a desert landscape, and that's a no-go. And so what can be done to sustain the health of urban trees? I think we have to be reasonable about the performance expectations of the various species. And that reasonableness changes in time. You should already note, if you've been a webinar attendee, that the nursery stake is on this newly planted oak. It's in the classical retrofit DG landscape that is going on everywhere. And it's a Quercus agrifolia, or a coast live oak, that just went through the 120-degree day in Ojai. And of course it fried it and it killed it. And so this is a combination of bad horticulture, unreasonable expectations, and climate change. So we have to adjust our expectations. And the native species may not be the best adapted tree for this urban environment. And I think that's something you have to be clear about. A native plant isn't going to perform in this environment better than, say, some exotic tree like I don't know, I was thinking of a tipu tree. A tipu tree probably would have survived this. This coast live oak did not. We have to provide the necessary resources for success. And this will be mulch, which you see none of here. You see decomposed granite. That's not really a good mulch for trees, as it's not organic. And irrigation. And not so much fertilizer, not so much pesticides. We need to provide room for the tree to grow both above and below the ground. And we need to, again, emphasizing, cultivate the adapted species for the site. And that may be something in flux. We may be changing what that is simply by way of something that's out of our control, i.e. climate change. We have to monitor for pests, pathogens, and damage, and we'll talk a lot more about that next week. And we have to visit or examine the tree at least once per year. I know that sounds silly, but a lot of times trees are put in place by other people that are gone. They don't ever come back. And I think consumers of horticulture products and services need to have their professionals come back to the site and see how things are going. Are they performing as they expect them to perform? And, you know, I learned a long time ago, I talked about this in one of the other webinars, that one of the most valuable $300 checks I ever wrote was to my vet for teaching me how to put horseshoes on a horse. I paid for that knowledge. And I think it was money well spent. Well, apply the same thinking to your horticulture people. You know, hire people that know something and then pay them for their knowledge. It's so critical. And we don't often appreciate the value of that until we go down that path, and then we benefit from it. We got some good advice and we paid for that advice, and it benefited our landscape or our trees. That's so critical. So limit, remove, or reduce hardscape. You know, hardscape is not always the best thing for trees. It will cut down on water use, though. You're not watering the hardscape. We need to develop a kind of mulch specification. And I have to tell you, this just isn't it. Okay, this picture is not it. First of all, we need to keep the cars off the mulched area. That's something that Ukraine needs to learn. But the mulched areas need to be thick. They need to be at least 4 inches thick, and they need to be replenished semi-annually or annually. And they should have a strong woody component. Composts are not good mulches. We need to apply these mulches to the largest area that is possible to simulate litter fall within the landscape. So next time, that's my final point. Next time we're going to talk about pathogens and how and why we have them and how we deal with them in cultivating trees. And I hope you can join me next week for the final webinar. Another reminder, the webinars are recorded. The recordings are available if you missed earlier ones. And this one will become available to you as well. And I will take some questions now.
Well, there's 1.5 billion of them, and I was getting through some of them. A couple are stories, so we'll try and get through those as best I can without stumbling. Can you relate the difference between biochar and composting? The differences, since areas with high wildfire are not going to be able to necessarily, through ordinance, be applying the same kinds of mulches that we're recommending.
Boy, is that question ever a loaded one.
Right?
I mean, I admit I gave a loaded seminar giving you all these dangling ideas. That was my intention, to provoke thought. But
Worked.
that question really provokes a lot of response. And
You have
first
about
of
20 questions. Okay, maybe 27. So
oh,
FYI.
okay, first of all, fire and mulches are poorly understood and little researched, and the policy developed about it is wrong, basically, just wrong. So that's all I'll say about that. Biochar, the difference between biochar and mulches, I can get 5 yards of fresh wood chips for free in some places with the chip drop program. I can't get 5 cubic feet of biochar to save my frickin' life. It's an availability issue. Biochar is not available to you. That's the
Even if
problem.
it is available, that's a young industry, and the research on biochar is still evolving. There are differences in the quality of the outcome based on the feedstock used for biochar production. Not all biochar is comparable to one another. So that's something to bear in mind if you're investigating biochar.
The other thing is biochar is also dead. And it just came out of a pyrolization process, a low oxygen burning process. And it's sterile, basically. Now, it can be invaded by microbes later, and that's part of the exciting research of biochar and how it has some disease controlling properties. But it's fundamentally different from fresh wood chips. Fresh wood chips is a living thing and is going to keep on living once you apply it. Okay, Tracy, go on.
So based on your comments about environmental pollution potential from piles of compost or piles of mulch rather, if you are moving litter fall from your property into the forest over decades, is that going to be problematic over
From
years?
your property to the forest?
Yeah, like if you have like say you're up in Mount Baldy or something and you have a backyard that's the national forest.
Yeah, I see. Maybe I don't know.
I
I
mean, the
guess
point
that
is that phosphorus starts to be a problem over time, right?
yeah. I mean, in a closed system where a tree is generating its litter and it's falling on the ground and breaking down, that's a continual process, and the input matches the output. But if you're just backing up your truck and dumping, that's like the analogy I mentioned earlier with the farmer and the yard waste from LA. It's gonna it's gonna be toxic at some point, or harmful in some way. Anyway, next.
Okay. Every time I have had a soil test done for my veggie garden, it comes back with high P levels. Imagine that. I mulch leaves, etc., into my garden every year. They ask if I've added bone meal, which would, and you have not. Okay, so just mulching fresh limbs, leaves, etc., could cause this.
It could, and also there's the option that you may have a soil with a lot of phosphorus in it. Naturally, I mean, some soils have phosphorus. Their parent material has phosphate rocks. I mean, yours might be one of those. So you're always going to have a lot of phosphorus in a soil test. Does it mean it's interfering with plant growth? Well, that's a much more complicated question to answer, I think. And certainly, you wouldn't want to add phosphorus to a soil like that. You will by adding fresh mulch to a small degree.
Oh, I'm sorry.
Go ahead.
You got
Yeah.
the age-old, we always get it at least once, allelopathy question.
Oh,
Eucalyptus and walnut.
okay. What's the actual question?
Comment on possible allelopathy from mulch materials from certain trees, eucalyptus, walnut.
Okay, well, let me explain that very briefly. Allelopathy is the interference of the growth of one plant by the growth of another plant. That is two living organisms interacting with each other. So in other words, the living walnut tree producing exudates or chemicals that interfere with the growth of something else. When you take that walnut tree or that eucalyptus tree and put it in a chipper, it is no longer living. Therefore, by definition, whatever interference occurs is not allelopathy. And if you go a little bit further and actually look for studies that show chemical interference from products made from plants like eucalyptus and walnut as applied mulches, it all falls apart and there isn't any. So basically it's a myth. Allelopathy from walnut and eucalyptus and all these things is basically not supported in science.
What happens to soil and if you mix the mulch into the soil?
Okay, if you mix the mulch into the soil, you get the soil full of mulch. And is that a good thing or a bad thing? Depends on your time frame. So eventually it gets all fungused up and starts to break down. And initially nitrogen might be immobilized, so plants would not have enough. But the mulch will start to break down and the soil returns to productivity. So initially you could have a draw of nitrogen away from the plant. Long term, it just makes the soil a better place. But we generally, the definition of a mulch is something that goes on the soil surface. It is not mixed in it. Once it's mixed in it, it is an amendment, and that is a totally different discussion. And that is a discussion wherein composts have a real role, okay, where we want to use composts as amendments. We don't want to use composts as mulches because they don't do the same things that mulches do so well, which is inhibit weeds, prevent evaporation from the soil surface, those sort of things.
I think you answered this already, but would you recommend mulching annually or does it depend on soil type or type of mulch used? Sure.
Yes, it depends. And also on kind of what you're growing. But you mulch to maintain the layer, this breaking down layer of organic material. And so you're mulching to keep this microbial process going. Microbes need the fresh carbon, and so you have to re-add. And it depends because moisture levels, have you had a lot of moisture? Is the moisture constant? Temperature. Mulch breaks down faster in warmer climates. So depending on where you live, you may be mulching semi-annually or quarterly. So all those things depend, yeah.
This one is an interesting comment, but I think there's value in responding to it.
Okay.
The comment. My son has some great pics of mulch that was piled high and heated up because of high moisture to the point of killing some young trees. So don't overdo it. Yes, absolutely. Can you speak more on that topic? Because I do think the toxins, et cetera, are important.
Yeah, that's an interesting comment. You're right, Tracy. You're so right. You're always right. So here's another place we get that happening. These yard waste distribution centers, they collect the yard waste and they put it in a pile after they chip it. And the pile might be 20 feet tall. And there's enough moisture in the feedstock to get it composting. But then the pile is so big, there's no oxygen in the middle. And you go into a kind of anaerobic fermentation in the middle of those piles. And you start to produce compounds that are plant toxins. They're short chain acids, they're gases, there's other things going on. And so if the pile is big enough, wet enough, and doesn't have oxygen, you're going to produce some chemicals from the feedstocks that are not desirable for your tree. The other thing that you could produce is just heat. And so these things get so hot, if they're right up against the tree and it's a thin bark tree, well, they're going to damage tissue just from the heat. So good comments.
I have a tree service at my house right now. I have asked them to dump the tree chips, leaves, etc. My neighbor has a tree of heaven. I'm so sorry for you. Should I use the chips from that nasty tree or let the service guys haul it away? The leaves are fine.
What would you say, Tracy?
I'm saying the leaves are fine. Leaves is chipped material from a tree of heaven. They just reek.
I would take it.
Yeah, I mean, they smell bad. Some people find the smell of tree of heaven, acceptable. But what you do want to watch for is that is a rhizome producing tree that will grow from rhizomes, including large rhizomes in mulch. So you might want to be aware of that.
If you have any doubts about it, leave it in the pile for a week and that usually settles it.
I'm just fertilized. Okay, mine are never fertilized. There you go. Um, what is the best way to keep the canopy healthy? I have a forest behind my house in Virginia. Move to
Uh,
California. I'm sorry. I have identified being healthy. Also growing closer than 6 feet apart. Yeah, that sounds like a forest. I hired an arborist to cut some of the trees down. Will this help the healthy trees?
Well, yeah, in
And
places like that, trees are competing with one another. It's a struggle. The ones that get the advantage of the sunlight and grow above are going to win. And um, thinning the forest will make the remaining trees have more nutrients, more water, more everything. So they're going to grow more. And yeah, in areas sort of to the east of the Mississippi River, if you don't mow it, it turns into a forest. And it's usually not a pretty forest. It's a tangle and a lot of competition.
I have a Chilean mesquite that was beautiful for over 4 years. Now, in year 5, it's lost all its leaves. My tree was a multi-stem. It's in Orange County, in a raised berm.
Mm-hmm.
Not done anything different. Leaves are starting to come back. 4 inches of mulch. Chilean mesquite are messy. Why? What's happening? Help me.
Well,
I think there's more to that question.
these diagnostics are rough. We don't know a lot of things like pathogens, yes, no, present, absent, buried too deep, yes, no, irrigated how much, yes, no. But I will tell you, having a nice coarse mulch under your mesquite gives it somewhere for all of its little leaves to fall without, you having to do anything, which is a good thing. That mulch shouldn't be up against the stem, and it shouldn't be a multi in the first place. But they sell those trees as multis so much, and it's an issue. Most of the time, the problem with those plants is they grow too fast in Orange County and they break out. And we tend to over irrigate them as well. So there's a lot of problems with growing those mesquites, I think, in Southern California that we need to learn how to leave them alone and irrigate them a little less.
So many people, I use the term biochar, and apparently that's foreign to many people on the webinar. So if you could be
Oh,
more
really?
specific on the definition of what biochar is.
Okay, so biochar is where you take an organic material like wood and you burn it in a very low oxygen environment. You're basically making charcoal out of it and you get the energy out of it. And when that process is done, the waste product looks like charcoal, biochar. And it's kind of tied up with some of these stories of ancient people having charcoal in the jungle that supported the growth of plants in some new great way that was spectacular, that looked intended. And so there's a bit of mythology behind it. But biochar as a commercial product is undergone the process called pyrolization. And pyrols form in low oxygen environment and they yield energy. It's like a flameless burn, basically. You're burning this stuff without flames. And when it's all done, it's the carbon has all been converted into this waste product and it's called biochar. So then people found out that you could use that product in soil and it would increase nutrient holding capacity. It would increase some microbial activities. It would prevent some diseases. It's like this magic, the newest magic snake oil voodoo amendment that's going to solve all the agricultural productivity problems in the world. But the problem is biochar to this day is still not a huge process to the point where we have enough of the leftover waste product to utilize in agriculture. So it's got some interesting properties. A lot of research is and has been done on it to suggest that it's a useful horticultural amendment. I don't know of any biochar mulch studies. I know of none. I don't think that's even been thought about.
There was a big meta-analysis that I read that was pretty interesting, but there's still, I don't think it considered it as mulch either.
No, it's like throwing charcoal briquettes down on your yard. I mean, it's black.
And
So,
it's either, in chunks or it's tiny.
or yeah, pelletized or processed in some way. So yeah, there's a lot. To me, the biggest impracticality of biochar is it's like buying peat moss on steroids in terms of cost. It's really expensive. The people who want to sell it to you think they're selling you God's gift to horticulture. And so it's really expensive. And what is the benefit of it? Is it worth all that money? And then honestly, I don't know where I would go right now to buy it if I wanted it. There's just not that much of it out there.
Can you speak again, just to clarify one more time on the sheet mulching? I know you spoke about that last webinar.
Okay. I didn't talk about sheet mulching today.
Not today, though. Yeah, correct.
So when you say sheet mulching, I'm thinking cardboard on the ground and something on top of the cardboard.
Yep.
Also analogous lasagna mulching.
Yep.
And the problem we have with that is that it's not, first of all, there's no research showing that it is good. And then there's some research by Linda Chalker Scott showing that it impedes gas exchange. So you're not cultivating that soil environment with high gas flow, which is what we talked about, where roots want to grow and all that. And we have similar feelings about root barriers and weed fabrics and landscape fabrics. They're all in the category of we don't like them. And sheet mulching is in that category as well. And so we don't advocate sheet mulching. Basically, there's a lack of science on it. I'd love to see a good practical sheet mulching experiment done to actually give us some data on this, but so far I have not seen it.
We were told not to have wood chip thicker than 3 inches because 4 to 6 inches deep mulch can hold subsurface burns for months.
Really?
Again, the research on mulch contributions to forest fires and continuation of fires is limited.
To say the least. Subsurface burns, though, can go on for months, but for other reasons, like they're on top of a natural oil seep. That's the one we see in our county. We have areas where oil is native, it's just coming out of the ground. A forest fire goes across that, sets it on fire, and it burns underground for years sometimes. But that's because there's something worth burning down there. 4 to 6 inches of mulch is not going to pose that problem. And that's exactly the amount we recommend applying and maintaining, 4 to 6 inches deep. And certainly not right around the stem. You would taper it off where the main stem is, but in the area over the roots, that's what we like to see.
You mentioned compost should be used as an amendment. A local nursery owner sells sterile soil with no organic matter present because he states that organic matter breaking down competes for oxygen and nitrogen necessary for root growth. Yeah, get a new nursery owner.
Yeah, I think nurseries are the cauldron of pseudoscience, and people come up with the craziest stories I've ever heard. And usually there's some tie to the product that they're trying to sell you. And so, I distrust anybody who's making money on information in that way.
Daniel, no, trees smoldering in the forest for 5 years are not becoming biochar necessarily. That combustion process is under pressure. So biochar production is a little bit more technical than just a smoldering fire in the forest for a long time.
Yeah.
Let's see. Newspaper. No. Let me go back up. There was a question up here. How do we balance mulching and allowing our forests to have dead organic matter with forest fire management? We're getting a lot of these forest fire questions. I think we're mostly talking about landscape, but
Yeah, I mean, those are valid questions, especially where there's a wildland interface,
it's
you
tough.
know, and you're living next to that. But, you know, I have somewhat philosophical opinions on that because I am living that life. I have a significant investment in property right next to I mean, I showed you the picture of a forest full of dead branches. And my approach to that is right next to my house. I keep that mofo irrigated. You know, I put a sprinkler out there, and when it's dry, I get it wet. And I don't take away the dead branches of the organic matter. That's part of the forest. You know, I view things from a natural perspective. Forest fires are natural. Organic matter on the ground is natural. Litter fall is a natural process. It's what keeps the forest healthy. So is fire. I chose to buy a house in this area where there could be a fire risk. That was my choice. Okay. That doesn't mean I go rake up all the organic matter and take it away. That's kind of dumb in my opinion. That's trying to do something that's going to save me from an event I can't save myself from, in my opinion. And so again, this is a philosophical discussion now, not a science-based one. And there's very little science about the flammability of the organic understory. And there's a lot of policy about that, but not a lot of science. And I think, you know, water is a key thing here. Water, wind, and fuel. You start moving those parameters around, and then you see when things burn down. The other big part about this, and I'm on a bit of a high horse now, and I'll get off shortly, but why is it we build flammable objects like houses where there's a lot of fuel? If we're going to have a house where there's a lot of fuel, you want to build an inflammable object. And so we're just now coming to the idea that it's not the trees that are flammable so much, it's the houses. And so, you know, we saw great imagery from Northern California with the fires we've had in California, where there's standing living trees and the whole goddamn neighborhood is burnt to cinders. There's rubble of houses that were burnt down to the ground, but the trees next to them are still alive. What does that tell you? It's not the tree that's so flammable, it's the house. And so, you know, we don't want to put flammable. I'm not going to put a wood shingled house next to a bunch of fuel and expect to survive a bad fire. Anyway, it's a philosophical discussion. It really needs a pub and beer. But anyway, what else have we got, Tracy?
Let's see. There's the love this question every time. How should coral trees be managed other than removing them?
Oh, that is such a great question. Thank you. Thank you, whoever wrote that. The coral tree that grows here in the Chiricahua Mountains gets to about 3 feet. And I kid you not, it's a native erythrina. It's called the coral bean, and it has bright red seeds. It's the most beautiful little Christmas tree. It's about knee high to your knee. Okay. It doesn't get above your head ever here. And that's because it's growing here. This is the northern end of its native range, and water regulates how big it gets. It doesn't get big. Now, if you go down into tropical Mexico, the coral bean is a big tree. Okay. And it gets big, and maybe it breaks there. I don't know. We take coral trees, we grow them in clay soils on irrigated landscapes. We irrigate the crap out of them. They grow big, they grow soft, they grow badly, and they're pruned badly to not deal with structural pruning and branch faults. And of course, they fall apart. It's like asking for it. Coral trees in Southern California should be considered drought tolerant and grown as such. And I love coral trees. Why can't they be beautiful in a deserty kind of landscape? They can be. Just nobody uses them that way. They put them in a tall fescue lawn and wonder 10 years later what happened. Again, not adapted plant material, not adapted to each other. Don't do that. Don't put coral trees in lawns and irrigate them every day and watch them grow like monsters and then complain that they got too big. I'm sorry, that's just being stupid horticulturally.
Horticultural stupidity.
Oh God.
But we become, it's more like horticultural ignorance. We're becoming
Yeah, you're
horticulturally,
so kind.
right?
Yeah,
So your
you're
people here
generous,
are
Tracy.
asking you the right questions. This is good. Can you speak to tools, specifically tools on measuring soil moisture to decide how much water is needed? I'm wondering, she's asking if a 24-inch soil moisture probe is appropriate. Maybe.
Yeah, I guess um there are a lot of them. Okay, so we can go everywhere from a neutron probe, which you have to have a license to use because it uses a radiation source. And that's one of the most accurate ways of getting water measurements in soil there is for research, to a screwdriver that you stick in the ground, or a, a metal rod with a pointy end and a handle on it that you just push in. And so, there's everything from extremely high technology to sense the actual amount of water to very low technology. And I kind of like the low technology, actually digging up the soil, see if it's wet or not at certain depths. You don't have to do that too many times to eventually understand and predict what the soil moisture will be based on your tree, your soil, your environment. You get a pretty good feel pretty fast. And then trees are resilient. They can tolerate being saturated for a while. They can tolerate being pretty dry for quite a while. And so it's not like we have to hit this ball out of the mark and keep the soil moisture matrix potential at exactly 100 centibars, or 50 centibars or whatever constantly. We don't have to do that. We don't need that amount of precision to cultivate trees. So I give you permission to overwater your tree and underwater your tree
On occasion.
on occasion, as long as it isn't all the time and causing some horrible stress. But trees have a wide latitude of dealing with these things.
Okay, yeah. So the next question I think is a fascinating one, because this is something that I actually do in my own landscape. I have a number of citrus trees myself, about 15, and I have an infestation of Earhart veldtgrass, which is a perennial invasive grass. Instead of using herbicides on it, I weed whip it and allow that grass to just fall back into my soil base as part of my mulching system. So this person is asking, what are your thoughts about using a living mulch? Is that
Uh,
compatible with the needs of a tree?
well, I think a tree would like, and again, so many questions have qualification answers, but if a tree is like a coast live oak that wants to grow right to the ground with its limbs on the ground, nothing grows under there. That thing is shades out everything. And so your living mulch is not going to live there. It's just going to be covered in leaves. It's going to be drowned in litterfall and deprived of sunlight. And that tree is going to be 100% happy with that. Okay. Now let's take it to the other end of the spectrum. I have this apple orchard out here. Right now, if I showed you a picture of it, it looks like a lawn with apple trees planted in it with all this understory growth that's growing under there. And it's because the apple trees just can't shade out yet all that herbage. So I have to mow it, throw down I usually mow it without collecting the clippings. So they just fall into there and it becomes recycled into the soil. And so we do this in agriculture too. The pecan orchards out here, some of them have green manure, if you will, or a crop in the rows, and they mow it. There's some advantage to it because you get pollinator diversity, you get a lot of different insects coming to those plants under the trees. So there's a certain ecology to it all. But going back to the qualifications, it depends on what you're growing.
Daniel just kind of stated perhaps older trees, not young trees, but I'm not sure what the context was because I didn't see when that came in.
Oh, okay.
Um,
Well, age of tree does impact a lot of things because a younger tree, a lot more sunlight falling around the outside of it, things are going to grow. You know, you think about sort of the evolution, not evolutionary, but the cycle of life of a big tree. I look out my window, there's some big oak trees out there. Is there much growing under them? No. They shade everything out and they drop leaves all over it. So there's not much growing under those trees. And then because they're large trees, they suck up all the water. Go look under a large eucalyptus tree and see how things are doing. Um, they're very competitive. So in time, a tree changes the environment and what's going to grow under it changes. A young tree is going to have a different situation.
so this is an interesting question in terms of there are aspects of it that I don't think are appropriate for this webinar, but the question is brought up about appropriate mulch for areas that are impacted by sudden oak disease, sudden oak death. Is
Well,
there one?
Stephen Swain is the expert on this, and he's a plant pathologist in Marin County. He works for Cooperative Extension. He did his PhD on sudden oak death and compost and mulch. And so I would defer to what he has to say about it. But they found that sudden oak death, Phytophthora ramorum, I believe, is not a good survivor in those circumstances. It survives better epiphytically on bay trees and stuff like that as a leaf spot organism where it really gets going. But most Phytophtheras do not survive well and can't survive well in highly organic, particularly wood chip environments. Because when you have fungi in there rotting the wood, they're making cellulase, and that's going to wipe out Phytophthora because Phytophthора's got cellulose cell walls. So it's not going to survive a wood chip environment with a bunch of wood decay fungi growing in it, which is the exact thing you want to create that suppressive soil. Anyway.
Oh, he says Dr. Harrison, a circle of grass-free areas for good tree growth is what he was referring to. Yes, that is correct.
Okay.
We also don't want grass growing up to the base of trees because they are injured by weed whips and lawnmowers, but that's another discussion.
Yeah, and that's a really interesting one too.
Yeah. Will green waste materials, chip mulch, affect mixed landscape plantings equally in a good way? And second to that, which is kind of related, what about using green waste from a vegetable garden for mulch?
Well, mulch for what? You know, mulch for vegetables? Sure. Mulch for shade trees, it's just not going to last long because there's no wood in it. Wood is recalcitrant. It takes time for the fungi to break it down. And so they have a longer lifespan in that stuff. Herbaceous green things that have been chopped up, they just don't, it's like lawn clippings. You throw lawn clippings down under a shrub or something, you come back a few weeks later, they're gone. And so,
Except when you're piling them repetitively under the same shrub.
yeah, and lots of it.
Yeah.
And they make this mucky, greasy layer. But the great thing about tree trimmings mulch is that it lasts for a while. And so it's giving you some protection of the soil surface that you don't have to worry about for a while. It's going to be there. It's going to work for you. But with, very herbaceous kinds of mulches, I'm not saying they're bad or wrong. It's just they're not going to be around for very long.
We were asked if you and I do other quality live webinars similar to this one.
We're working on it.
We also do an in-person soil school for arborists, which is an event over 3 days teaching arborists about the properties of soils at a kind of captive location. So that's something that's fun. Is there a lot of traditional ecological knowledge about controlled burns that did prevent larger forest fires? Isn't there a lot of information?
I think we're getting into fire science that I'm not an expert on. Controlled burns is a completely different thing. And There's a lot of philosophy about that too. You know, if you let the forest burn, you wouldn't need to do controlled burns, right? So
Well,
there's a bunch of thinking that, you know, our controlling forest fires has been one of the big problems. We basically controlled these things, and then we have a huge buildup of fuel over huge acreages that creates something that we can't control anymore once it catches on fire. So there's a lot of philosophy about that too, but I'm not a fire science advisor, and I'll defer to others that are, because there are some really good, there's some good talent in UC on that area.
that information is also evolving because what once was done when there was a house and a lot of farmland is different now than a forest next to $1 million homes. So, you
Yeah,
know,
I'm thinking of that Oakland fire a few years back.
yeah.
It was really, you know, devastating. And, you know, a lot of houses, a lot of fuel, a lot of tragedy.
So mulching for desert trees, that's a very good question coming in from Carol. You,
Okay.
you haven't spoken much about type of mulch for desert trees. What do you recommend?
Same thing, wood chip mulch,
So the larger
preferably.
wood chips are nice because they're heavy, right?
Yeah. You know, I've seen some interesting things since I've been poking around in the desert. And one of them is that um, desert plants all have mulch, and you don't think about it because it's almost invisible, but you get down on your hands and knees and you look what's falling into the rocks, and all those little microfills from the palo verdes, they fall on the ground, they become part of that system. And they're more transient, they happen and they go away pretty quickly. It's like the tide, watching it come and go, but it's part of the process. And then I've seen some other interesting things in Tucson. When we had the annual meeting there for the Western chapter, I have pictures of rock mulched areas, and it looks like just rock, but you get on your hands and knees and you look at it, it's full of little stems and rachuses and leaflets from the tree above that had fallen in there, and the rocks had captured it. It didn't blow away because the rocks are holding it in place. And there's an interaction between organic matter and rock that I think isn't carefully studied that would be really fascinating to study, where we have rocks that can trap the leaves. And we see this out here in the Chiricahuas with the sycamore leaves. They get trapped in the rocks and the other features of the landscape, and then they break down. So I think rock has a role to play in mulching that isn't quite as obvious as you might think it is.
But also, as you look at rock as a potential mulch, you want to realize that there is a difference in the heat signature from the various sizes of the rock that you might consider. So some rock can be large enough or in a condition that can contribute to a heat island effect, and other rock less so. So that's something that has not been researched much as far as I know either. But having taken heat signatures from various sizes of rocks, I personally am aware that they do have that, and that information is available, that rocks do hold heat differently based on their shape and size. That
And,
information is available. The impacts on plants is less researched.
and I think the woody mulches dissipate heat more. Rock holds heat.
Absolutely, that was also shown to be part of that.
And and I know from my own research on that very first study I did on sycamores, I looked at heat and I looked at reflected light. And the reflectance is different off of different mulches. Composts tend to be really dark and they absorb a lot of light. Some of the wood chip products reflect a lot more light up into the canopy, and they can reflect photosynthetically active light. And so you might get a growth stimulation from some mulches just because of reflected PAR that you don't get from other mulches. So it's a complex thing, and there is some other research on that as well.
And Carol, I looked at this for a different webinar that I was presenting at Desert Green in Nevada. So I have information that was gathered together, not from a single source, on the heat signatures for the rock that I investigated. So I don't have a discrete set of data for you.
I can
Maybe we should evolve that.
There's a, Carol, you might want to look at Linda Chalker Scott's review article on mulch. It was in 2007. And
You talk about rock in that? Heat signatures of rock?
I can't remember. She just runs over the whole thing.
Okay.
And but there might be something in that paper on this subject. And there was another review article that I often refer to about mulch by Robinson in 1985 in Hort Science. He did a good review paper, but Linda's was the most recent in 2007.
Linda Chalker Scott, 2007. There you go. Okay, so we are down to, let's see, oh my goodness, they just keep coming in. I love that. Okay, so that was answered live. Can you comment on the old standby use of the nursery bought redwood compost?
Okay, I want to talk about that
redwood
one.
mulch. Oh my goodness, yes, please.
So here's the thing I remember about this. Tam junipers, this is from my childhood, and those big chunks of conifer or redwood bark, the big things that float in water, and I swear to God, they're still out there somewhere under a tam juniper today because they never break down. I didn't talk about bark mulches, but bark is full of waxy material called suberin in the periderm, and it's made to be impervious. It's made to resist moisture, insects, fungi, weathering, fire, everything. And so you put that stuff down on the landscape and it sits there and it does, microbially speaking, nothing. It will cut down evaporation. It'll do that for you. It'll protect the soil surface from the sun. It does a few of those mulchy things, may prevent weeds, but it adds nothing microbially to your soil in terms of carbon or food webs or any of that. So the bark mulches are, I can't say they don't do things because they do, but they're not like putting down wood chips that are microbially stimulating, shall we say. Okay.
Okay. That's pretty much exhausted our Q&A for this webinar.
Oh, we still have 100 people on the line. It must be all about the banter. So
we do
Tracy and I
we are told. Thank you.
We're trying to evolve this idea, which we haven't yet. And do I have permission to talk about it?
Yes, I guess so.
We're talking about doing something like crucial conversations about trees in a podcast kind of format where we have guests and it's like a conversation. And it's not really a presentation, it's a conversation. And so Tracy and I are evolving this concept for a future online kind of thing. So maybe we'll come to that sometime.
Yeah, your coral tree situation, I'm just so sorry.
Oh.
For your coral tree situation, I recommend that you contract a qualified certified arborist who can come and evaluate the structural integrity of the root system so that it can be
hammocks for teenagers to hang in. I know it will fall. Oh my God, that sounds horrendous.
Yeah.
You know.
Oh. And thank you, Carol. Yeah, so those trees are problematic. How they are grown, particularly in West Los Angeles, Malibu, Santa Monica areas where they are getting a tremendous amount of water all of the time. They just grow very rapidly. They're very weak wooded and just prone to structural failure. Their native range where they grow slowly, they have very dense wood and they don't fail in the ways that they do. It's our management, the way they're grown in California, that contributes to their weak structural strength. So yeah, with the root cut and all of that, I would definitely have somebody evaluate that before you have something bad happen.
One of the purposes of this webinar series is to try to get people to pay for knowledge. This webinar is free, but I'm telling you, don't hesitate to hire somebody and pay for their opinions. Hire somebody who knows something. and then move from that standpoint into your action to hire a contractor or somebody to actually do the work. Don't hire the worker to give you an opinion. This is the wrong way of going about it. It's like going outside and talking to your gardener and saying, oh, could you tell me about the physiology of this Acer palmatum?
I
And
hear
he's
you,
going
Jonathan. We'll get to it. Sorry, James.
to, yeah, and he'll look at you like, you want to know how to cut your tree, lady?
Man, because all the women already know how to cut their trees.
That's right.
So
Or
he's
they're
asking
men.
about the Monterey pines with pine bark beetle, and is that an impact of drought historically as well as currently?
Oh, it's a couple of things. It's the impact of growing a Monterey pine in the wrong place, for one, and then not cultivating it correctly. That is, maybe you planted too many in one area and now they're competing with each other and there's not enough water, sunlight, or resources to sustain them. And maybe they're in an area where it's just too dry. They're not near the coast, and they'll grow there fine for a while, but then eventually the stress is too great. And these things are beetle magnets. Ips paraconfusus, five-spined engraver beetle, loves these things to death. And I mean to death. And so the red turpentine beetle loves them down at the bottom on the lower trunk.
Up to 4 feet.
And then the cone beetles love to eat the tips of the tree. So, you just get, and then the plant pathogens like pine pitch canker love them if you are growing them near the coast. So, the problem is Monterey pine. The genetics of Monterey pine don't want it to grow outside of Monterey too much.
Right. Yeah, I'm sorry. I was just reading Arlene's comment, and she was praising us for our down-to-earth ability, presentation, and ability to provide usable information. So thank you for that. Yeah.
And common sense.
Common sense. I live for common sense. How are we going to test salinity in xylem sap in the field? I don't know yet. Yeah. So absolutely. We have now exhausted our Q&A, and we're down to 87 people who are enjoying our banter.
The banter. So unless you put another question in there, we're going to say sayonara and see you next week.
Race to the question. Our fingers are flying. Okay.
And I guess I'll remind everyone, and I'll put in the chat. Second, I have to modify it so everybody sees it. My email address. For those who want to ask questions privately, you're more than welcome to. And, I also wanted to say I do appreciate your emails. They've been really interesting. They make me think a little bit outside the box, and I have to do that because of the wide regionality of our audience. And so that's been fun. I may not have the answer for your area. I may tell you to go get a certified arborist in, Michigan or wherever you are, because they know what's going on there. We had an interesting question about a borer attacking a poplar tree. I'd never seen the insect before, but the person asking the question was able to get the information from their local extension service in Texas or wherever he was. So next webinar is next week at this time, Thursday at 12:30.
Same link you used for this one. You are already signed up. If you sign up once, you're signed up with that link for all of these webinars that we are providing.
Yeah, some people we know, Alexa had to go off, but she's tracked some people registering 10 times. And that's kind of why we have a lot of people registered, because people think they have to re-register every week, and you don't. So
and okay, they like our humor too. So I appreciate that, because I have been to so many webinars lately, and listening to somebody just kind of droll on in front of the camera is really annoying. So I hope our interaction and energy is also helpful to you in your learning.
And keep asking questions. The webinar's over, but that doesn't mean you have to not ask questions. Sometimes I know for me, the question doesn't come until the next day or a week or something. And I go, wow, they said that, but what about this? And so,
Yeah.
the questions keep coming and keep asking the questions. That's what keeps us giving you the answers.
And thanks for
And
joining us from Australia. Dr. Downer actually has been to Australia and can speak on some of the topics that are pertinent to Australia. If you have specific questions, he might not for insects and pathogens, but in general, he is pretty well traveled. And so, if you are from other areas, we certainly hope that he can respond to more targeted questions from you in those areas.
And I for the 60 people that are left, I want to say something about that, Tracy. And that is that when I've traveled to wherever it is, it's always been a mind tweak to me to see what plants are growing together. Like I remember going to Carnarvon Gorge in Australia. It was in, I think it's Queensland or New South Wales or right near the juncture, but it's inland and it's like the Grand Canyon of Australia. Well, on that place, when we were hiking, I went through a forest of Corymbia maculata, which is called the
Spotted.
gum,
Spotted.
spotted gum, I think. And I thought, wow, this is the coolest forest. But what was shocking was the understory. It was like cycads and all kinds of other weird things. And so when you're thinking then of designing a landscape, is your architect going to think of putting Corymbia maculata and these cycads that grow native with it? No, it would totally not occur to you. Out here in Arizona, we have agaves growing right next to oak trees. And I mean right at the base of an oak tree, agave with an oak tree. That is such a natural thing here. Would I have thought to do that before? No, I would never put an agave with an oak tree.
What a great way to keep squirrels out, though.
But and it's a natural feature of the landscape here. And people even from climbing your tree. But whenever you travel, you see these great plant partnerships that you had no idea about. And people who live there take it for granted. Oh yeah, we know about that. But
Right?
when someone's designing your landscape, I don't think they know about that. And
No, that's
so,
true. So, like, we talked about when we went to the East Coast at the National Arboretum, how the liquid ambars and the crepe myrtles were so huge and beautiful and glorious.
yeah,
And here in California, they're stunted and, you know, sad. And then I was watching with my daughter last night a period piece film, and it was set in England. And there was this, I think it was probably a 60-foot tall purple leaf plum,
wow.
which grows there beautifully and looks like a sad little twig in Southern California. So,
Especially after Xylella gets done with it.
right? And all kind, I mean, flat-headed borers, everything that hates it. But I mean, it's a glorious tree, but not here.
Yeah, and I think for me, I didn't start going anywhere traveling wise as an adult. I went on vacations with my family as a kid when I wasn't thinking about horticulture, right? But as an adult, I didn't start to travel anywhere until my 50s or something. And so I didn't have the appreciation I do now for horticulture on a worldwide basis. And it definitely is an eye opener to go places and see how it's different. Another big shocker for me was going to Thailand and seeing street trees in Thailand where I thought all the streets were paved with green, right? You think that in Thailand, everything has to be lush and beautiful and big. And you know what? I saw some of the most miserable street trees in Thailand as anywhere because the urban environment is just as toxic in Thailand as it is in Minnesota
Or Los
or,
Angeles.
or, Leiden in the Netherlands, whatever. And so I think that's the other thing you see is how universal treatment of trees is around the world. Even when you have the advantage of rainfall and humidity and tropical things, where you can get away with some of this. But yeah. So cities are bad for trees. That's the answer to everything.
But we need trees in cities.
We sure do. We need to find out how to grow trees in cities better
Yes.
and then do more of it. And I wonder about those pictures you see on Facebook of the high, buildings with all the trees growing on the building, the green buildings. That's freaking not sustainable, man. What's going to happen when those things get big and fall off the building?
They crane in a new one, just like they do at Disneyland.
Yeah, but it's got to go bada boom sometime.
Yeah,
What's it going to hit?
I don't know, because a lot of the
Tree
trees,
failures from the 33rd story? I mean, really?
a lot of the trees at the museum, what museum is that over there? Off of the 405.
Oh, in LA?
Yeah, because it just
Uh,
left my brain. Anyway, they're in vaults.
oh, the
Those trees
Getty.
yeah, the Getty. They're all in vaults. Below the trees that are in vaults is a parking garage.
So in theory, then the vault should restrict the growth to a degree.
Right. I would think
Yeah.
so.
Unless they pump it full of, fertilizer.
Well, we don't know, right? So it'll be interesting to watch over time.
It's
All right. So
that demon compost that's going to cause them to overgrow the vault and fall off onto the tram and kill somebody.
we are at 250 now, or 240, and we've exhausted our question bank. So I think we're pretty much done for this webinar. If you want
Okay,
to
we'll see all y'all next
comments?
week.
Any additional comments? And I believe you have to hit leave for all and end the recording.
I think so, but I was just going to scroll through these comments and see what people said before I go away.
Okay. You have 37 people still online.
All right. Well, thank you, everybody. It's been a fun conversation, and I hope you guys learned something along the way. And next week, we'll get into pathology and maybe a little entomology. Take care, everybody.